Okay, so today is the first session of this Big Data PySpark with AWS classes. Okay, and what is the agenda for today? So we'll try to understand, what is data. Okay, we all know these things. How the evolution of data started. Okay, so how big data or like how data is big. We'll try to understand that in terms of some technologies. Okay, then after that we'll try to understand the types of data which we are getting nowadays. Okay, so we'll try to understand types of data, then what are the challenges which are being faced, okay, to store and process this data, and then we will understand how Hadoop came into the market. Okay, how Hadoop was introduced, who introduced, what that person saw. Okay, we'll try to understand that, and finally we'll try to invest our time in Hadoop 1.x architecture. Okay, so this is like what I have planned for architect. I make frequent typo errors, so this is like what has been planned for today. Okay, so this is like what I would be taking for today, and let's see how it goes, whether we are getting enough sufficient time to do this, not to do that. So based on that we will be able to do. Okay, cool. So let's start with the first thing is, and that is nothing but what is data. Okay, we all know. So any suggestions, like what do you mean by what is data to you? What does data to mean to you? Can I say like data is some information, or can I say like data is a collection of facts, and that facts could be in like numbers, or maybe like words, or maybe kind measurements, anything, whatever. It's like just a simple like a definition which I'm trying to derive. What is data to you? Okay, so data is nothing but a information which we see, and we try to derive some meaning out of it. Okay, so that is nothing but a data. So any suggestions like you can give according to you? See, it's not necessary you need to be bang on your answers. Here we are learn and to explore. Until unless you don't say, I will not be able to measure like at what depth you are and what kind of learning you are learning from me and you are progressing. So for that purpose you need to speak and you need to share your thoughts. And once you start sharing your thoughts, it will help you in the long run. The reason is, as soon as you start sharing the thoughts in interview also, it will help you so that you start building that process, and whenever you are in interview you would be able to say those things. Okay, but not mandatory. Again, like any thoughts, and like what does data means to you? For me, it's like a
Yeah,
piece of information, right? Anything
yes,
extra which you can add?
yeah, I would like to add. So, data in the sense that could be structure, unstructure, or semi-structure, and that form would be in text, image,
Correct.
in fact, in
Yes, yes.
voice, and the manner, the speed, or the storage. Those problems are being
Okay, thank you so
suffered.
much. Thank you so much. So you're going very advanced, but again, like your answers are correct. And always say your name, because initially 2 3 weeks I'll have to recognize your voice and I'll get your name. Thank you for answering. Yes, whatever he has answered, again, that is correct, but a little advanced. So we were just speaking in a layman's language. What does data mean to us? So for me or for everyone, or even if we go outside, we will ask, what is data? He will say, data is nothing but some information which is kept on paper or anywhere, or let's say on mobile, or let's say on laptop. So here also, if you see, this is nothing but data, right? It's piece of some information that is in the form of some words, right? It can be in the form of facts, it can be in the form of numbers, it can be in the form of measurements. So we are just trying to understand. It will be nowhere asked, but let's we are starting from basics. Okay, cool. So I will just give you a small example how this evolution of data started. Okay, we all know that evolution of data happened at some place, but how that happened? Okay, let's understand a small example, and I have just taken a small diagram to be ready with us. Okay, So I've just taken few examples like 60s, 70s, 80s, 90s, 95 and 2000s. Okay. So let me take an example. When I was in plus 2 or when I was doing my engineering, okay, at that moment of time, I used to use floppy disk. People like may be able to recall like data storage at that moment of time. So like floppy disk, like 1 MB of floppy disk, or let's say pen drive. Okay. So at that moment of time, at that era, that was the latest technology and it meant a lot to us, right? So in a similar fashion, in the early days, the technologies were not so evolved. So there were few mechanisms wherein like data used to be available. Okay. So are you not able to see this? I hope you are able to see the notepad, right?
Yes, yes.
Okay, cool.
Yes.
So now let's the example which I was saying is in the early 1960s. Okay, so let's say in 1960s, let's try to derive some example. Okay, let's say in the early days. Okay, and let's take an example of Saif. Okay, what we will do is, let's say Saif has a shop. Let's say he has a shop. Okay, now in 1960s, in his shop, like there were some items or there were some products kept. Okay, customers used to come, they used to buy the products by paying the price. Okay, so there was an exchange of products in terms of money. Okay, so let's say in the early 1960s, Saif had only one shop, and the customers used to come, they buy the products, give the money, Saif used to give, and everything was happening fine. And what he used to do is, if you remember or if you recall, whenever you go into some general stores, they will try to jot whatever things you are trying to do. Okay, so they will try to jot on some notebooks, right? So let's say in the early days also similarly. Okay, so what Saif used to do is, Saif used to store this data in a text file. So that was I am trying to show a small example. Okay, so we know how the data is getting stored in text files. Okay, it's not in a proper format, that is scattered. However I will write, the data will be getting stored. But again, like I had only one shop, so at that moment of time I don't have much business and much thing to store or much thing to manage. For one shop I would have managed easily. So as the time passed from 1960s, once a decade passed in 1970, what happened is Saif business started growing. Let's say he started from one shop and now he has two shops. Just for a small example, just to simulate small example. Now it was becoming a very no, it wasn't becoming so difficult, but again, like let's to simulate an example. In 1970s, I was not able to store or I was not able to process the same information in text files. So at that moment of time, the technology started evolving by time. So we had text files and then we got DBMS, which is nothing but your database management services. Any example of DBMS?
Fox Pro,
Fox Pro, good.
Oracle.
Can we say like MS Access in simple words?
Yes. MySQL.
Yeah. So can I say like MS Access, or let's say Excel files, or let's not say MS, but at least MS Access, like wherein like we are trying to manage certain things in a proper manner, as compared to text files, a little advanced, where the things are managed properly. So the option which was given to Seth for two shops, someone suggested, why don't you use DBMS and store and manage your data? So he said, let me try that. And when he was using that Microsoft Access, he was happy with that. But he was not able to identify like the records. Like let's say there were two shops. Let's say at one place Saif is there and another place is, let's say his friend is there. Let's say Ram. So these two people are at two different places, and they are selling and they are trying to keep their data DB access, sorry, MS access at the individual places. So just to combine and everything, okay, so they were not able to do appropriately. Means like they were able to do at their own end, but again when it comes to collide, so let's say Ram used to store the Parleji product name like in other fashion, and Seb used to store in another fashion. So the mismatches used to come, the data duplicacy used to come. There were few problems. We'll not dig into those problems and will not go into a lot of depth, because this is just like a understanding like how data got evolved. Okay, so let's say after a few decades, again like his shop got increased from two. So the issue was in early 1960s, he was mentioning all the information in text files. Then as his business started growing, he started maintaining in like DBMS kind of database management system. Now again, like as his system, as his business got grown, what he did is he started facing issue, and that's where like someone asked him, why don't you use RDBMS and maintain everything in a proper manner? So that's where like relational database management system came into picture. Okay, we all know like Oracle, SQL Server, and so on. There are so many, just to name a few. So here, Saif was able. There, let's say there were three shops at three states. Okay, and it was centrally integrated with the relational database management system. So integrity and constraints were levied, and they were able to access the information in a right manner with a proper structured and with a proper meta store, which means like some integrity. And so even if there are three shops at three different states, so the product name would be the same across the three places. That's how they used to define the structure in RDBMS. So he was happy with that. So I'm just trying to give small gist on this. I won't go a little depth because architecture is where we have to go in depth. Okay. In a similar fashion from 1980s, okay, so the RDBMS, then the era came of data warehouse. That's where like people from ETL will be able to relate. What was the problem of RDBMS, okay, and how like your data warehouse came into picture. So in 1990s, your data warehouse started evolving because the data was growing huge. It was growing in numbers. RDBMS was able to handle, but when it came to like querying the data, when it retrieving the information from the millions of records, at that moment of time, the query response or the latency was high. Okay, and the end users needed that information in a pretty good quick manner for some strategic decisions. So for that purpose in 1990s, data warehousing got evolved. Like the father of data warehousing, like Bill Inman and Ralph Kimball, okay, they suggested some approach like top down and bottom up approach, okay, and they started doing things. We'll not go into those things, but here like ETL tools came into picture. So if you see, we started from text files, how the technology started evolving. We started from text files, we got some database management access, we got some RDBMS, then we got some ETL tools. Even if you see, then once again, like maybe like after a decade, the ETL tools again, they were giving the performance, not that they were not giving performance, but again like the era started of like, as someone answered a little earlier, the data kind of like was in different types of formats. It was like unstructured and semi-structured. At that moment of time, these data warehouses or these sophisticated tools which were available in early days were not able to help us. Okay, for that, in 1995, the distributed file system came into picture. Don't worry about these things. I will be explaining with everything properly. This is just, I'm trying to give you a small gist. What is DFS? DFS is nothing but your distributed file system. Okay, and then the data started evolving a lot, and that's where like big data started coming into the market. Okay, so this is just a small journey which I have shown, wherein the data started evolving, okay, and the technology started evolving. So just a small gist, I'm trying to show how the data started evolving. From a decade to decade, what technology was supporting. Now, if you see, we are in the era, means we are in like 20s, okay. Now we are working on on-premise. Maybe down the line after 1 year or 2 year, whatever we are trying to do or whatever we are trying to do now has already started migrating to cloud, okay. But we might get an opportunity now, or maybe like a 6 month later, 1 year later, or 2 year later. That's the future for us, and that's well covered in this entire 4 months training program nicely, so that you will be ready for the cloud as well. Okay, so this is how your evaluation of data happened, and again, like data is growing humongously. Now, if you see, everyone is looking for the data. Let's take a present scenario. We are going in the COVID situation, right? So if you see, vaccines are being given, but again, if you just try to think on those terms, if you try to visualize on those terms, okay, so when they started working on the vaccine, they had a very few data, means in the sense like what kind of syndrome they are, what kind of syndrome people are getting, okay, what are the molecules are there, okay. I don't want to go into those scientific terms, but again, like you are like, until unless they don't get data, okay, if I'm trying to give 1,000 medicines, sorry, 1,000 doses to, let's say, 1,000 people, what are the response of the 1,000 peoples? Based on the data, is my medicine is good or not? So before giving this try on a human trial, they try to do these trials on animals. Based on that data, they decide whether these medicines are perfect to release in the market or not. But if you see, that's what has happened in COVID scenario also. Based on data, we are doing something. Let's take an example of elections, right? So if you see, whenever the elections get started, okay, people start their journey of announcing, okay, and they start like doing their marketing. And let's say when the election day comes, if you turn on any news channels, you would be getting certain information. And from where that information is getting, that information is based on data, right? Correct? Let's take an example of cricket matches. Maybe like few people might be interested, as I am interested. So if you see, like whenever we are trying to when we are trying to watch cricket matches, we get scores, we get averages, we get tweets. This question is asking, that question is asked. Okay, we get that analysis report of LBW, ball tracking report, so on. Now, how they are trying to use these technologies? Okay, few are like streaming technologies, but again, for that streaming technologies and real-time technologies do need data, right? So that's where, like nowadays, in today's world, data is very important to us. Not only to us, to organizations also. Okay, so that's where the data is a new oil. You have might have heard this term. So data is a new oil. Okay, so we just understood like simple definition of data and how data evolved. Let's try to understand in terms of computer language how big is the data. We all know, but let's understand like till where we know. Okay, it's not like I just need to just understand or just explain. Okay, we all know in the computer's language, okay, what we know is, let's say, 8 bits makes how much? It makes 1 byte, right? Sorry for the typo, which will always be there.
Yes, right.
Yeah, thank you so much, and always respond whenever you are trying to answer. I would expect your name so that I can relate your voice to your name, and soon I will recognize you. So okay, so 8 bits is equal to 1 byte. Then we have 1024 byte, okay, and that will be making to my how much?
One kilobyte.
Beautiful, thank you so much. So let's go for 1 kilobyte. Again, if I say 1024 KB, okay, that will be making my 1 megabyte.
MB.
Cool. Sorry. Again, my 1024 megabyte, okay, will be making to my 1 1
Gigabyte.
GB.
gigabyte.
1 GB.
1 GB, which we all say. Okay, now 1 gigabyte will be making my 1
Terabyte.
beautiful. So one, let's say 1024 of my terabytes will be making my
Petabyte.
1 petabyte.
okay. Okay. So if you see in the industries nowadays, the data is being processed in terabytes and petabytes. Okay. So that huge is real. But again, let's move ahead. Let's move ahead. So 1024 petabytes of data, how much that will be?
1 gigabyte, I think.
1
Gigabyte.
gigabyte.
Yeah.
No, it will be 1 exabyte.
Exabyte.
Okay. So now see all these terminologies we don't know because we never went to that extent, and like because we know like terabytes of hard disk, okay, we know that. Petabytes also know, but there are industries who are processing this huge amount of the data like in terabytes and petabytes, and even like yottabytes and bottabytes. Let's complete this. So let's say 1024 of exabytes, okay, 1024 of exabytes makes how much? 1
Petabyte.
1
ZB.
ZB. Beautiful. Thank you so much. 1024 zettabyte. So let's say 1024 of my zettabytes, it is making how much? 1 1 yontobyte. 1024 yontobyte is making me like 1 brontotype. Okay? And the last is nothing but 1024 brontotype is making like 1 geotype. This is what I know. I don't know whether like something has upgraded, but the last knowledge which I have is this. If you see, there are industries who are processing this humongous data nowadays also, but we know like in terabytes or gigabytes. Okay, so we need to understand like processing of such humongous and large volume of the data, how efficiently we can process, and at the same time how efficiently we can store this humongous amount of the data. So when we are talking about this huge volume of the data, what is the challenge for us as a IT developer? Okay, so the challenge is how will you store this huge volume of the data, and the second is how will you process this huge amount of the data, right? We'll come to these challenges slowly, but as of now, there are industries like who are processing this kind of the data and this kind of the data also. If you if you take an example of stock markets, okay, if you take an example of airline industries, okay, there are so many industries like manufacturing firms, retail firms, okay, banking, like investment banking. They're generating so much of data every second, right? So these data needs to be stored at some place, and at the same time data security needs to be there, and after storage you need to process that efficiently also to remove some insights, to answer some strategic decisions which are asked by high management people. So to answer this, in the early days, at different eras there were some different technologies. Okay, so in the early days, like it was like text files. By doing something on text files you need to get some answers, and as the technology started growing you got DBMS, RDBMS, data warehouse, and I need to explain these two terms. Okay, so if you understand, like if you are able to see this kind of data, like what I am trying to show you over here, so I'm just trying to make you understand about the data. We have not at all entered into Hadoop. Okay, so the amount of the data which is getting generated and it is getting processed nowadays in the industries, that is tremendous and at a very large scale. So the earlier systems which we had, or the traditional applications which we had, no doubt they were able to process it and handle it, but they were not efficient. It's not that they were not able to process and handle it. Sometimes they used to break, sometimes, but again, like they used to provide you with the answers. but the answers they used to get, that was not the expected time frame which people were requiring for. Because nowadays, if you see, the competition is so high that you need an answer immediately. Okay, if someone is doing that, what I can do better to improve my thing? If we compare two banks, let's say HDFC and ICICI. Let's take an example of HDFC. They have a product, and that product is personal loan. And if we take an example of a product called personal loan, when the HDFC bank is trying to sell a product in the market that is personal loan, they are able to sell more. But when we are trying, means like, let's say an ICICI is not able to sell more. Now how ICICI bank and how HDFC bank will come to know whether they are selling more and whether they are selling less? Based on numbers, based on data, right? And let's say if ICICI bank wants to improve their performance of their sales, what they have to do? Either they will have to improve their product, they will have to improve the rate of interest, or they will have to analyze what HDFC is doing better that I am not able to do in my product. Is my sales team not good enough? Is my product is not good enough? Or the market where I'm trying to sell the product, that market is not relevant for that product? And how these questions will be answered? Based on certain data, right? So for that perspective, someone is not on mute. For that perspective, data becomes very important. And that's where we are learning this technology to answer these two challenges of storage and process with the help of Hadoop that we will be seeing later. Okay, so understood like what is data and in what huge volume of data is what we are getting in just basic terms, whatever we have seen. Any questions till now? Yes, no?
No,
That's good.
No, sir.
no, sir.
Okay, cool. So again, like it's very basic and we all know these things, but just like reiteration of few things. Okay, now if we understood this, it can happen. People might ask, what is big data? Right? They will ask you, what is big data to you? See, for me, it would be big data would be different. For you, it would be data would be different. And for others, it would be different. For me, it could be like 1 petabyte could be like a big data. For you, it could be like 1 GB could be a big data. For others, it could be different. Based on the applications, based on the requirement, based on the type of the data, the terminologies would be different. Okay. So I'm just taking a small pause for response, Irfan. So let's understand what is big data terminology, or let's say if a person asks you what is big data, so I would say, okay, big data is nothing. Okay, big data is nothing. It is the term of collection of data. Okay, that is so large and complex. Okay, so that is so large and complex that it that it becomes difficult to difficult to process using on hand, let's say using on hand traditional applications. I would say traditional applications, or traditional application is fine, whatever, like it's just like in terms of my own words. Because if you see, as we were seeing the evolution of the data at different era, there were some different applications or some databases which were processing some kind of the data at that moment of time. Okay, but nowadays, as someone answered earlier, the data which we are getting is so huge and large, and it's just a complex, so that my earlier traditional or my previous applications which used to process, now they are not able to process nicely. So that's where like I would define, okay, this is big data for me. Okay, so big data is nothing but a collection of data that is large and complex, that it becomes difficult to process. Okay, Because if I try to give you no doubt nowadays all those applications and traditional RDBMS and data warehouses tools also have started upgrading themselves, no doubts in that. But again, like if I give those things, some people like will be means like some tools like big data Hadoop, again it has also evolved like from where to where. So if I give that unstructured, semi-structured or structured data in terms of petabytes or exabytes or zettabytes, that would be able to process gracefully. And again, like storage, it will be able to store very nicely. Okay. Now, if we take an example like how data was evolving, so we gave some examples of like stock markets. Okay, let's say when at the time of elections also, if you see the data is like again like generated huge. So like sensor applications, okay, so same way like your array applications, so all they are generating data. Retail applications, investment banking, all they are generating data like in a huge manner. So I would term them as a big data for me. Now, as someone said, okay, if you are getting a data and you have described that is large and complex, but what type of data you are getting, again like to decide or types of data, there are lots of V's are available which you all know, but I will just take 3 or 4 which are very much important. So the first one is nothing but a volume. Okay, if you remember, like I was trying to give an example in my early days, I used to use floppy disk or a pen drive, and that used to be like of 1 MB. But if I go to buy a pen drive now, I'm getting the same pen drive in like 128 GB or maybe 256 GB also. And that processing speed also has become so fast, data transfer, either from laptop to pen drive or vice versa. Okay, so if you see the storage, okay, if you see the storage and processing has also become fast with the applications that has come into the market. It's not only storage and processing, that also is there, but again like when you are trying to do this, how efficient your tools are. So if you see today's pen drive, which is like 3.0, they are much faster as you compare to the previous gen pen drives. That's how your technology is growing, right? If you take an example of your laptops, in the early days we used to have 2 GB RAM laptop, 4 GB RAM laptop, but nowadays if you see, and like a i3 or let's say second gen, third gen, fourth gen, but now if you see 7 gen, 10 gen, i7, i9, we are getting SSD. Okay, early days we didn't know what was SSD, but nowadays people are opting for SSD. People are opting for external storages. People are opting for storage and processing. Even in everything, if you just look around you, you will be able to see something related to big data in every meaning. If you take an example of let's say TVs, okay, or mobiles, electronics, or let's say bank account also. I am coming from that era where I used to have a passbook. Okay, so where I used to go to the bank, stand in a queue, fill the pay slip, and get the amount from my account. So I'm coming from that era. But if you see nowadays, you can open an account on the fly. You will get a credit card on a fly. You will do all your transactions on a fly. How the technology is evolving in every department. Okay, as the technology is evolving because of some data which is again in different formats. So the speed at which the data is growing. So if we speak about the volume, we just saw the type of the data which is getting volumes. So early days, like let's say MBs or GBs, but nowadays if you see, let's take some terabytes and petabytes data we are going to process if we go into the projects. When it comes to velocity, if you remember like or if you recall, in the early days, like I am coming from an ETL background, so I used to process my data daily. Every day my batch used to run, and they used to run from morning sometime and they used to run till the afternoon. And if some failures used to occur, production support team used to look into that, and they used to resolve that, and they used to ad hocly submit, and again, like, my job execution used to get started. And let's say if due to some reason my previous application is not completed, my next application doesn't used to get started. But if you see nowadays, people are processing like every 3 hours, every 2 hours. If you talk about streaming application, every minute the data is being processed. So the velocity is nothing but speed at which you are getting the data. Okay. Then comes the variety of the data which we talked about. Someone said, like, I am able to see the data of images, audios, videos, okay, and etc etc. Let's say weblogs, okay, etc etc. So the data which I am processing nowadays, it's in a form of variety. It's not the old format of, let's say, .dat file or .txt file, wherein I will be getting the same format of the data. Because if you go into the projects, you would be getting the data in a Parquet format, you would be getting the data in a complex JSON format, you would be getting the data in an Excel format. How will you process that data efficiently? How will you store that data in a good manner so that it would be efficiently stored? So that's like your variety of the data. Then again comes like veracity. Again, this is like veracity. What it means is, someone is not on mute, I guess. So what does veracity means is, okay, how consistent your data is. Okay, how consistent your data is coming. Just to take a small example, let's say there are three columns: ID, name, and let's say city. So let's say I have got a first record. It's, let's say, 101. Name is Saif. Okay, he's in Mumbai. Let's say I have one more record. So let's say Obed. Okay, so let's say he's in Gurgaon. Let's say there is one more record. Let's say 103. Okay, and let's say the name is missing, and let's say the city is also missing. Something like that. Let's say there is one more record, 10. Let's say this is missing, and let's say the city which we are getting is, let's say the name which we are getting is, let's say, Ram, and let's say he is in, let's say, Bangalore. So if you are getting these kind of the data, like, how efficiently are you handling the data? So that's like your veracity of the data, how consistent data you are getting, and with that of the data, like, how are you processing that data. So these are the fours which are always required for the for you to get your ROI. That is nothing but your return of investment. Because if we or the industries are investing their money, they will be always expecting a ROI. What is my ROI on this? Even if we take an example of you, of us, okay? So few people have joined this course, right? So if we have joined this course, why we have joined this course? For a 4 month, you are trying to associate with me for learning this big data, PySpark with AWS, and in turn, what you want to have? You want to have a job switch. So what you are trying to do? You are trying to invest your time. You are trying to invest your effort. You are trying to invest your money, and in turn, you want a job switch. That is your ROI. That is nothing but return of investment from this 4 months of training. In a similar fashion, when industries are putting their money on some projects, they are also expecting an ROI. That's where that's where these types of the data decides how we can process the data efficiently and what value we can derive. That's where your fifth V comes, which is nothing but your ROI. That is nothing but return on investment. So these are like your 3 or 4 V's which you'll have to remember. Like, what is the volume of the data which we are processing? Okay, if we are processing this volume of the data, at what speed we are processing? What types of the data we are getting? And what is the veracity of the data? So we need to think on all these terms whenever we are processing or whenever we are doing big data. And that's where your value will come out of it. that is nothing but ROI. Okay, so this is something related to your types of data. Okay, as someone suggested, okay, so we'll just take this, and maybe like after this maybe we'll take a 5-10 minutes break. So let's understand, like, as someone said, like, where we are getting structured data. Okay, we are getting semi structured data. Okay, also we are getting unstructured data. Okay, so if we are talking about, if we are taking an example of structured data, we all know like ERP systems, okay, CRMs, or we can say like a relational database management system, RDBMS. So these are your example of your structured data, wherein like your data is in some good format. When it comes to your semi-structured data, we can talk about XMLs, we can talk about email, okay,
CSV also there.
CSV is also there. So there are different types of semi-structured data. So let's write this in small format. When we talk about unstructured data, so as someone suggested earlier, we are like audio data, we are getting images like blobs, globs. In that we get sometime images and we store that. So sometimes we get archived documents also, we get logs,
Logs.
yeah, we get logs, okay, we get server logs, etc, etc. So these kind of different types of data we should be able to handle, or even if we are not able to, yeah, we should be able to handle, but we need to understand what is the technology, what it is helping us. So as the data is growing, as the type of the data is coming in a variety format, the volume is huge. Okay, there are challenges of, to me, of my storage and processing. So this is like what I came to a conclusion for now. Okay, we started like understanding what is data, then we understood like what is big data, okay, the how the data was growing, okay, and now we need to understand, if we are getting such a huge volume of the data and in this format, how will I store the data and how will I process the data? So this is a challenge for us for now. We know the
One question.
solution, but again, like,
Yeah,
for now we will take that, okay, this is like a problem statement in our hand. Yeah, someone was saying something.
yeah. Sorry to interrupt you.
Sure.
So one question here, I'm little bit not convinced like the log and server log is under unstructured because of there is a specific pattern in log itself. So it could be considered as a semi-structured.
uh Again, like, see, again, like, it's a debatable topic. You might have encountered with like logs which kind is of a semi-structured data. I can take that, it does not make a mean to me, but I have got some logs wherein the data is scattered in like anywhere. Maybe like we will be seeing that in one of our scenario ahead. So there was a scenario in my project where we were getting the logs, and that logs were like all, means like all scattered here and there. Again, like, it's like, again, means like how we get the data and how we are differentiating on the data. It can be a scenario wherein like we are getting a logs that will be like a little wavered, so I can term that in that semi structured. Yes, we can do that, no issues. It's not that this is a fixed terminology. Okay, so I'm just trying to relate with some examples. But the logs, if you are getting that is in an encrypted format or in a binary format, that the moment of time you'll not be able to handle that, or you'll not be able to term that in a like a semi structure, right? It again based on the data. I do take your point. There are certain logs which can fall into certain semi structured category as well as into unstructured category. It all based what type of log we are getting, right? So if we are getting like a binary logs or a Parquet, like all those encrypted logs, we cannot term that into a semi-structured, right? Yes, no?
Yes, sir.
Yeah. Purely depends on data. You see, it's not that these are the terms which I am saying that is 100% right. It's always like, again, like, it's a debatable things. we can come up with few things, but what I have seen, I'm just sharing my experiences. So that's what I said. Based on the data, those terms can move here and there, but the predominant things what we are trying to do is like structured, semi-structured, and unstructured. So for now, us, what is the challenge? How can we store this huge amount of the data, and how we can process this huge amount of the data, right? Now, yeah, so let's take a quick break of 5 minutes. Okay, so we understood now how data is important to us, what types of data we are getting, okay, what is the variety of the data we are getting, and how the huge volume of data we are getting. So the challenges for us is how I will store this and how I will process this. Okay, now here there was a person who came into the market and helped us, and let's try to understand that. Okay, so now we will try to understand history of Hadoop. Okay, so when I would be explaining the history of Hadoop, at that moment of time, the point which I left unexplained, I will be explaining you. Okay, let's understand the history of Hadoop. Okay, cool. Again, it's good to know knowledge. Okay, not mandatory. So good to know knowledge. So we start means like the invention started in year 2002. Okay, now there were two people. Okay, so they were working on a nudge project. Okay, who were those people? So nudge project was started by Doug Cutting and Mike Caffarella. Okay, these were the two people who started the nudge project. Don't ask like what is nudge project, what it has involved. So we'll just understand the history, and once we understand where Hadoop came into picture and what it provided the solution to eradicate these business problems, then we'll start deep diving into our core contents. Okay? Okay. So in 2002, Nudge project was started by Doug Cutting and Mike Caffarella. Okay, let's understand what this project had. Okay, so this all started in the year 2002 in Apache Nudge project, which they called. Okay, so what Doug Cutting and Mike Caffarella were working on this project, what they were trying to do. Okay, they were trying to aim or create a web searching engine that would crawl and index websites. This was the project which had Nudge involved. It means like Nudge project was about searching a web search engine that would crawl and index websites, and you all know Google is again doing the same thing. So they were trying to work on this. So these two gentlemen, Doug Cutting and Mike Caffarella, they were working on a Nudge project, and what they were trying to achieve, they were trying to build a web search engine that would crawl and index websites. Okay, so that was the Nudge project. After a lot of research, Mike Caffarella and Doug Cutting estimated that the cost of this project is going huge, that is around $500,000 in hardware, and the monthly expenses for running this was $30,000 for a 1 billion page support indexes, and that was too much. So this project proved to be too expensive, and thus they found infeasible for indexing billions of web pages, because just to support a 1 billion page index, the cost is so much. Then indexing billions of pages, the cost will explode to a very big amount. So that's where they came to a conclusion: the project which they are working will not be feasible to them. Okay, so this is how the journey started. Okay, so then they started thinking on it. So they started looking here and there for some solutions, because they are also facing problems, right? How we are facing some problems, even they were facing some challenges. So they started looking for some solutions. At the same time, in year 2003, okay, what Google did is, because Google was able to do this implementation efficiently at that moment of time when these two gentlemen were thinking of that. So Google was already ahead. So what Google did in 2003, they released they released white papers on Google file system. What they did is, they released a white paper on Google file system. Now what is Google file system? Let's understand that. So when they released a search, when they released a white paper on GFS, that is nothing but Google file system, which is provided to store, or which can store large volume of data in a distributed manner. Let's write something. Large volume, or let's say store large volume of data in distributed manner. Okay, because Google was able to do that efficiently. So what they did is, just to help the industries, they released the white paper. They did not show how they are implementing. They just released the white papers of what? Storing the large volume of the data in distributed environment. Okay, in distributed environment, I would say. Okay, so when when these white papers were given by Google, okay, so this solved the problem of storing huge files or web crawl or indexing, which these guys were facing issues. Okay, so what they did is, they took this white paper of Google, which is nothing but GFS, okay, and started working on that, how to do this using, how to implement this using this white papers. And that's where your DFS came into picture, which is nothing but distributed file system. Okay, so what they did is, they took this GFS. Okay, let me take a new color, someone. Okay, so what they did is, they took this GFS, okay, and they solved this. How they did solve this? Let's try to understand that. Okay, now let's take an example of, let's say we are getting a file of, let's say 300 MB. Okay, what we are getting is, let's say we are getting a file of 300 MB. Okay, let's say I am getting a data of HDFC Bank, and in this HDFC Bank I am getting a data of, let's say, products. Okay, or let's say we are getting the data of loans, to be precise. Okay, and this, let's say, products, that was correct. And in this products, we are having variety of products, something like, let's say, so the products which we are having are nothing but, let's say, loans. Okay, let's say credit cards, let's say mortgage, and so on. Okay, so these are the products we are getting. Now when Duck Cutting and Mike Caffarella read this white papers, how did they solve the distributed environment of storing? So what they did is, whenever this is, okay, so let's say I'm building like three blocks, 1, 2 and 3. So when the request is coming, so let me just draw and then I'll start explaining. Okay, and this is going here, this is going here, and this is going simultaneously here. Okay, so what these two gentlemen did is, they took the white papers of Google, okay, and they started implementing how to store large volume of the data in a distributed environment. That is nothing but, they termed as HDFS. So I am telling as of now DFS, which is nothing but distributed file system. So what they did is, they took this white paper, and the amount of the data which we are getting is 100 MB. So in spite of storing entire data at a one place, they tried to break it, okay, and they started storing that data in a distributed manner. So 100 MB over here, 100 MB over here, and 100 MB over here. Okay, and let's take the same products, because I don't know, in this 300 MB, it can be a scenario like, it can go here also, it can go here also, because that data is random. I cannot segregate that until unless I write the code, right? So what these two gentlemen did is, they implemented the concept by reading the white papers given by Google, and they implemented that concept, that was nothing but DFS, which is nothing but distributed file system. So the data, when it is coming, whatever the amount of the data it is coming, okay, they are taking the data. After taking the data, they are distributing it in a distributed environment. So my storage is being efficient. But when a requirement is coming, let's say I want to get a data. So let's say what I want is, I want the data which are pertaining to loans only. So let's say I want to write a query. Let's say select all the records from my table, okay, where my product is equals to loans. So this ask, when this ask is coming from some user or from some end user or from some environment, what exactly was happening, the entire data which was segregated or distributed into a different distributed environment, that data was coming back to my process. Okay, so this data is coming back to my process. Even this data is coming to back to my process. An entire 300 MB of data is getting scanned for this piece of query. What was happening, I was able to store my data in a distributed manner efficiently. So the challenges which we had of storage, okay, that was solved using Google File System white papers, which is nothing but GFS, and that was like DFS, or you can say HDFS, Hadoop Distributed File System. So these two gentlemen were able to solve the problem. But when the requirement came to processing, again it had the same issue. So these two gentlemen solved only half of the process, which means that they were able to resolve this problem using Google white papers. Now, what is this called? When the data is coming to your process, this process is termed as process locality. What this process is termed? This process is termed as process locality, which means that my data is coming to the process and then it is getting computed. Okay, so in 2003, when Google released its white papers, these two gentlemen started working, and they took this white papers and they solved the problem of distributed storage, and that they named as Hadoop Distributed File System. If you are giving me 1 GB of the data, I will store that data in a distributed fashion into a commodity of cheap hardwares. So these two gentlemen were able to solve half of the problem. But when it comes to a process of solving the processing, still they were facing the issues. Then what happened? Then what happened is, in the year 2004, again they started looking for, hunting for some solution, and at the same time in year 2004, what Google did is, Google released white papers, okay, and that white papers was on MapReduce. So what these two gentlemen did is, they took some developers from the Nudge project, okay, and they started implementing a NDFS, okay. So that was termed as Nudge Distributed File System, NDFS I would say, okay. So they started implementing NDFS. So Google introduced MapReduce to the world by releasing a paper that was on MapReduce on the solution how to process large volume of data. Okay. So what these two gentlemen did is, okay, so they started working, they started looking at these white papers, okay, and they started implementing the same concept, and they termed as NDFS. Okay, what happened is, they took this same thing. Now let's understand. Okay, initially they were able to handle the problem of storage, but when the problem, where was the problem they were facing? They were facing the problem of processing, right? Because the implementation which they did earlier was process locality. But in 2004, when they saw the papers of Google of MapReduce implementation, they took some niche developers and started building a project, okay, and that project had NDFS and MapReduce, okay, how that was implemented, okay. So in that, what they did is, in spite of bringing the data to the process, what they did is they sent this process to the data. So what they were doing is they were mapping this process to the data, okay. So they were mapping over here, so I'm just not writing. So this is mapped, and let's say this is mapped. So what they took is they started taking the process to the data, they mapped it, okay, and let's say the requirement is select star from the table where a product is loans. Now if you see, when I'm trying to scan 100 MB of data on this distributed file system, at the same time even this is scanned. So when it is starting from here, when it is starting to scan from here, even it is starting from scan to here, even it is starting to scan from here. So in the earlier process, what was happening, all the data was coming to process and my entire data was getting scanned, and it was taking, let's say, 3 minutes. Now what is happening, they are getting scanned parallelly. So what they are trying to do is they are trying to map it, okay. Now let's say there are 5 records over here, let's say they found 3 records over here, and let's say they found 2 records. So now internally what it will do, this will go to a reduce phase. Don't worry about this, just understand the concept, okay. It's not mandatory for us to know these things, like how it will be internally, so it will be internally matter, but again, like how we will be writing the code, because that's where like PySpark will be coming into picture for us. So here what was happening internally, with some logic, the data was getting reduced on a certain machine, and that data was sent back to the user. So that's where map and reduce was implemented by these two gentlemen in the mid of 2004, and they named as NDFS and MapReduce. Okay, so in the mid of 2004, these two gentlemen were able to achieve the concepts or the implementation which Google was able to achieve easily. And what were those concepts? So one was GFS, which was Google File System for them, and MapReduce. So Google File System was NDFS for us, so for them, which is nothing but Nudge Distributed File System, and the second was MapReduce. So here what they did is they implemented a concept, and that concept is called data locality. What that concept is called? That concept is called data locality, which means that my process is going towards the data, getting computed over there in a parallel manner, and finally my result is sent back in spite of the entire data. That's where your processing in a distributed environment was efficiently achieved by these two gentlemen in mid of 2004. Okay, so even now they have solved using MapReduce, and they named as MapReduce only. Okay, so in 2004 they were able to solve this. Now what happened in 2006? Okay, so internally they it had a certain limitations. Okay, so like some limitation was like some 20 to 40 clusters, but what happened is this, in the year I think 2006 or 7, what they did is, okay, when they built this MapReduce and NDFS, okay, so the invention of Hadoop was done, okay, and this invention of Hadoop, okay, so was a combination of storage and processing, because storage was achieved by distributed file system, and processing was achieved via MapReduce distributed environment. So they were able to achieve storage and processing issues, and they named this technology as Hadoop, and we all know how this name was derived. So it was derived on duck cutting. Okay, so duck cutting kids, duck cutting kid was playing with a small toy, and that was elephant. Okay, that's where like duck cutting named this project as Hadoop, and this was implemented with a 20 to 40 nodes cluster. Don't worry about the terminology which I'm saying. I'll explain you node what I'm trying to say. In year 2006 or 7, what Yahoo did is Yahoo also started using Hadoop, but they implemented this on a 1,000 node cluster at a large level. Okay. Finally, in the year 2008, okay, finally in the year 2008, Hadoop became a top project in Apache. Okay, so Hadoop became a top project in Apache Foundation. Okay, it's an open source foundation. Okay, so again, like it has a story how it defeated the supercomputers, because what happened is like the Google Map reduce what it did is it sorted 1 terabyte of data in 68 seconds. So when they tried to compare the Google Map reduce, it was processing the data or sorting the data 1 terabyte in 68 seconds. So this was the benchmark. So 1 terabyte of the data was sorted in 68 seconds by Google. That was reported by them. It's not that I am seeing something or some blogs are saying something. So Google reported that its MapReduce sorted 1 terabyte of data in 68 seconds. So this was reported by Google. So what these guys did is in November 2008, if I'm able to recall, in 2009 something. So what Yahoo did is they tested Hadoop with 1 terabyte of the data, okay, and that sorted happened in 62 seconds. How many seconds? 62 seconds. And that's where they beated the Google MapReduce implementation. But again, that's not important for us. But again, like we just good to know knowledge, like how the data means like how the technology got evolved and how they got slowly up and up. In the year 2011, okay, in year 2011, Apache Foundation, that is nothing but Hadoop 1.0, was released in the market. Again, it had few bugs, it had few issues, that was taken slowly ahead. Okay, so Hadoop 1.0 released in the market in year 2012. Whatever the issues or the bugs which 1.0 or the drawbacks or the limitations it had, that was taken care in Hadoop 2.0 release. Sorry, Hadoop 2.0 release. Okay, we will see this Hadoop 1.x architecture. At that moment of time, we'll try to understand what was the problem and how it was overcome. And slowly the era got moving ahead as like how like our technology got evolved from one floppy disk from 1 megabyte to 1 megabyte pen drive to nowadays like 128 GB pen drive and so on. In a similar fashion, Hadoop also started evolving. Okay, as of now, Hadoop 3.0 is in market. Okay, but most of the organizations have not have not adopted 3.0 yet. More every means like in my means like most of the projects are working on Hadoop 2 version only, maybe like 2.9 or 2.7. Okay, those are the versions which we are working. But to say a scenario, okay, so as of now, Hadoop 3.1 I think 3.1.1 is
Fine.
3.15.
3.1.5.
Okay, it got upgraded. So 3.1.3 I know. So 3.1.5 is the latest version of Hadoop which is available in the market. Okay, so this is just a small history of Hadoop, how the invention of Hadoop came into picture. Okay, so with the help of GFS, which is nothing but Google, with the help of Google white papers, these two gentlemen, Doug Cutting and Mike Caffarella, were able to achieve a distributed storage and distributed processing, and they implemented this, and later on they donated this project to Apache, and now Apache Foundation is taking care of this project. That's how your challenges of your storage and processing were able to solve with the help of distributed storage, which is nothing but your process locality. It had a problem, but again, with the help of distributed processing, that problem was also removed. Okay, so that's how your distributed storage and distributed processing were achieved, and Hadoop was into the market. So are we able to get like how we got to know the problems and how these gentlemen helped us? Again, like, we are not going into the terms of practical implementation or coding, how did they do that, but we are just trying to understand like how the technology got evolved, what was the problem statement, who came us to help us, what they suggested us, what was the problem statement, and what they suggested us, and how industry is adapting and using those things. Any questions till here? Again, it's like a good to know knowledge, but very basic knowledge and introductory level knowledge, just to understand how it is and how it is not. Okay.
I say this Satyajit.
Yes,
Can you
Satyajit.
explain the process part of it?
First process, this is this one.
Yeah, like how the distributed manner it process the data.
Okay, let's come back over here. So distributed processing, right?
Yeah.
Okay.
Yes.
So if we take, like, let's say the same example. See, means, are you good? Like, what was the problem in DFS? Like, I was not able to process the data efficiently, but I was able to store the data efficiently. That is right, correct?
Yeah.
Okay. If we take the same example of 300 MB data, okay, now we are able to store 100 MB over here. We are able to store 100 MB over here and 100 MB over here, right? Okay, let's take a realistic example. Okay, so let's say Satyajit is a team leader. Okay, and let's say Irfan and let's say Obed. I'm just taking few random names which are coming to my memory, because I'm interacting, and that's why. So slowly I'll be getting to know all name. Okay, so Satyajit is a team leader. Okay, Irfan, Saif, Obed, and let's say Krishna. These four people, or let's say Krishna, Saif, and Obed, these three people are reporting to Satyajit. Okay, so three people are reporting to Satyajit. Now, what Satyajit as a team leader is doing, okay, Satyajit is giving, like, let's say, lots of work. Let's say he's getting a work, and let's divide that 100% work, we'll say that. So what he's doing is 50% work he's giving to Krishna, okay, 20% he's giving to Saif, and the remaining 30% he's giving to whom he is giving to? He's giving to Obed. This is what he's trying to do. So 30% is given over here. Let's take an example, 20%, and let's say 50%. Now, if they are trying to process this data, okay, so definitely Krishna will take time, right? Because he has a lot of data to process, or he has a lot of work to be done. That's why he will take time, right? Similarly, what Saif and as compared to Krishna, Saif and Obed will be able to complete their work a little faster. Why? Because they don't have much work. That's where, like, your processing distributed storage, when they are trying to do, again, like, it also has an internal mechanism. Now you will ask me a question: if you are getting a 300 MB of the data, how are you able to do this 100 MB over here, 100 MB over here, 100 MB over here? You could have asked me that question also. So in Hadoop 1.x and 2.x, there is a block configuration of 64 MB and 128 MB. If I take an example, okay, so 300 MB if I'm getting, and if I divide by 64, let's take approximately 5 blocks, which means that, let's say, 2 pieces will fall over here, two piece will fall over here and one piece. So I'll not go into that depth. So when explanation of distributed processing, we'll just give a simple layman example. So we are getting 300 MB of the data. So that 300 MB of the data is getting efficiently distributed 100 MB over here, 100 MB over here, and 100 MB over here. Storage is efficient, which means that Saif, Obed, and Krishna are getting equivalent work, which is, let's say, 33%, 0.33, 33.33, and 33.34. So efficient work has been distributed. Now, how efficient processing is happening? Now it can happen, okay? It can happen. Obed is faster, Krishna is faster, and Saif is a little slow. It can happen. Again, like there are some internal mechanism and there are some optimization process which we can see how to optimize that. But as of now, the storage is being done efficiently. Now, how to process it? Now, what is the mechanism? Let's say whatever the scenario is, let's say I want to find out the scenario which I have taken from my 300 MB of the data, I need to find out only loans data. So initially what was happening, entire 300 MB was coming back to the place and entire 300 MB was getting scanned from right from the start till the bottom, and it was taking 3 minutes. So I was not able to get my distributed processing power. I was able to get my distributed storage power. For distributed processing, in year 2004, Google released a white paper of MapReduce. What they told, don't bring the data to the process. Send the process to the data so that they will compute at different machines in parallel, and finally they will reduce, or whatever the data will be collected and finally will be sent to the user. So what they did is they sent this process to the data, and that process is called mapping the process to the data. So that is called map. Here also there is a map is getting applied, and here also that is map is getting applied. So my process is going towards the data. Now what is happening? I want to find the loans record. So it is trying to scan this 100 MB, this 100 MB, and this 100 MB simultaneously. Which means that if my 100 records are getting scanned in 1 minute, so even this will get scanned in 1 minute. Eventually, all these are getting scanned parallelly. It is not that once this is completed, this will start. It is not that once this is completed, this will start. Parallelly, this is also getting scanned, this is also getting scanned, this is also getting scanned. Why? Because your process is mapped to the data. Your process is mapped to the data. Got it? Now it started scanning. It got some records, as I took some few examples, 5 records, 3 record, and 2 record, and internally it collected all these 10 records, and final result was sent to the end user. So how much time it took? Here it took me 3 minutes, and here it took me 1 minute. So with the help of distributed processing, which is nothing but data locality, these two gentlemen, with the help of Google white papers, that is nothing but map, reduce, they were able to solve the problem of distributed processing. And that's where your distributed processing is helping over you. Are we able to understand?
Yeah, fine. Yeah.
Thanks, Satyajit. Any questions on distributed storage and distributed processing? I hope we are good. Everything is good so far, so good. Okay. Okay. And now let's try to understand Hadoop 1.x architecture. Okay. Again, which is not used by the industries, but we should know what was the architecture they gave us initially, what were the limitations or the drawbacks, which was overcome in the next release. Okay, that's what we'll try to understand now. Okay, so I would request, like, for this entire presentation, I would request you all to just hold on your questions, because some questions might answered when I'm explaining a little ahead, and finally we will be taking the question answers. Don't worry, it's not that I won't be answering. So the only thing is the link will be broken. Okay, so let's make a move to understand Hadoop 1.x architecture. Okay, so let's take a color which is nothing but black, which we can. So let's understand Hadoop 1.x architecture. Okay. Okay. In this Hadoop 1.x architecture, there are few components which will be coming. Okay. So we will be seeing those components and will try to understand those components. Okay. Okay. So let me just quickly draw few things which are required for this. So let's draw like a name node is required for us. Okay, so in name node, and there will be a secondary name node as a backup. Okay, so let's say I'm just drawing three data nodes, one, two, three data nodes. Okay, and there will be a client. Okay, so from the edge node the request would be sent to the cluster. So no need to bother what the terminologies which I'm trying to say, this that will come to you slowly, don't worry. So this is a client. Okay, so either you can say it's a client or it's an edge node. So tomorrow I will explain you with the machine what is edge node and what is client. Okay, as of now understand the terminology. Okay, so this is nothing but your name node. This is nothing but your secondary name node. Okay, then these are nothing but your data node. So it's a master slave architecture which they have given to us. So let me copy this, let me paste this, let me paste this. Okay, so if in the name node we have two people, so the first person is nothing but fs image and the second person is nothing but the edit logs. Okay, so these are the two people, and inside that again we have one person, and that person is nothing but a job tracker. Okay, so similarly we in here in the slave nodes we will have task tracker, and same thing over here, and the same thing over here. Okay, let's try to understand. Okay, so let's start with the explanation. I've just drawn few components here and there. Okay, we'll try to understand how this Hadoop 1.x architecture makes a sense or makes a meaning to us. Okay, let's understand that. So the first thing is in Hadoop 1.x, the block size. Okay, so the default block size Hadoop 1.x gave us was 64 MB, and again the default, whenever I say default, they are always configurable, which means that based on the requirement they can be increased or decreased. Okay, so the default block size in the 1.x architecture was 64 MB, and the replication factor was 3. In order to be highly available and to achieve fault tolerance, what Hadoop proposed us a replication factor of 3. We'll try to understand that. As of now, now these are the two things which we need to understand before. So these are the two things which I've already written. Now let's take a small file of can we take a file of 100 MB? Yeah, let's take a file of 100 MB. Okay, so it's a simple file of 100 MB in size. Okay, when I'm talking of a default size of 64 MB, if I divide 100 by 64, I'm getting something like 1.5. So which means like from 100, one block will be for 64 and the other block will be for 36. Okay, just for some small sense I'm trying to make out of this explanation. Okay, let's take an example. There is one block of 64 MB and there is one block of 36 MB. Okay, let's try to fill this with some colors so that it will look a little attractive to us. Okay, so this piece of block, so the first piece of block is nothing but it is having like 64 MB. Okay, and this is this is like 36. We are just taking a small scenario. Okay, cool. Now when this, what Hadoop 1.x architecture suggested, you have to have a block size of 64 MB whatever data you are getting, and you need to have a replication factor of 3. Good. Okay, now when the request is sent, okay, so when the request, sure, okay, before that let's try to understand first what is name node. Okay, let's try to understand this first. In the Hadoop architecture, let's try to understand what is, we'll come back to the explanation also. Okay, we'll understand name node. Okay, now name node is nothing but you can say it's a master. Okay, and the data nodes you can relate that as a slave. So there is a single instance of this process. Okay, which means that there will be always one name node in your Hadoop 1.x architecture. That's why I'm saying there is a single instance of this process which runs on a cluster. Now what is a cluster? Okay, cluster is nothing but a group of machines. So if I say this entire is a cluster, I can say this entire thing is a cluster, but this and this, they are nothing but machines. You can relate that. Okay, so let's say in just a layman language, 10 machines or 10 laptops will form one cluster. Okay, so as I'm talking about or talking the word or jargon, when I'm trying to say cluster, cluster is nothing but a group of machines. Okay, so there is a single instance of this process in a cluster. Okay, and that is master node. As I told you, it's a master slave architecture. That's why it is termed as master. Now what is the use of this name node? It is used to store metadata. Okay, so the use of this person is, it is used to store metadata of whom? About data node. So what is the metadata it might be storing? So it might be storing that how many blocks are stored in, I'll write short form from now onwards, DN data node, MN master node. Okay, so how many blocks are stored in data node? Okay, which data node have data? Okay, then what is the location of data nodes? Okay, what is the location, what details it has? Okay, what is the timestamp on it? So all these like information related to your data node is stored in your metadata. Okay, so what master node does, what name node does is, this process reads all metadata from a file, and that file is nothing but fs image. Okay, and keeps in memory, and keeps it in memory. Okay, and this process is started, and again like it eventually builds up using edit logs. I will tell you that. So what it does is it periodically writes, the changes in one file, and that file is called edit file, which is nothing but edit logs file. Okay, so this process is termed as, this process is nothing but your heart of HDFS. Okay, let's try to understand now When a request is coming from a client or an edge node, the request is going to your master node. Okay, and this is a 100 MB file. So when the request is coming of a 100 MB, a request is coming from a client or an edge node to process some data to a master node, internally what name node is doing, okay, it is trying to take this 100 MB file, okay, with the help of it knows like it needs to be broken into two pieces because the default block size is 64 MB. So it needs to it needs to send the data to the data nodes where the data will be processed. So name node is nothing but a master node where all the metadata of your data is kept. So that will be done. So when the request is sent, so what will happen, there can be a scenario. So with the help of block size 64 MB and 36 MB, okay, let's do quick copy paste. So what I will do is first control C, control V. Let's say this is available over here. Now we need to understand two things in the Hadoop 1.x architecture. Okay. Now blocks are written blocks are written in parallel. Okay, which means that whatever data which I had, whatever, let's say here I have like 100 MB data, so it got into two blocks. What if I had what if I had 200 MB of the data? Okay, so mostly I could have got 4 blocks, right? So these 4 blocks would have written parallelly. If you see immediately on data node 1 and data node 2, I have written simultaneously. So what happens? Blocks, let's take a color black. So what happens? Blocks are written in parallel. Okay, that is the first thing. Second thing is replication is done in sequential. Now what does replication means to us? They have told us just to be your cluster to be highly available and to be fault tolerant, you can replicate these blocks to a different nodes. Okay, we'll come to the concept of rack awareness at a later, but as of now we are just understanding the architecture. So what will happen once the successful blocks are written, once the successful pieces of blocks are written, they will start replicating to, I'll copy this, control C, control V. What will can happen, it can replicate over here, it can replicate over here. Okay, once this block is successfully written, then only your replication will happen, otherwise it won't happen. That's what I am saying. Blocks are written parallel, but replication is done in sequential manner. In a similar fashion, what would be done, this piece also, if it is successfully written, that would be replicated to different data nodes. Okay, so blocks are written in parallel, replication is done in sequential. So whenever like your blocks are replicated with the default configuration, okay, so they are being to be said replicate. Now there are two phases, and those two phases are like under replica and over replica. We will come to that later, but let's come back to the architecture. Okay, so we got a 100 MB file. The request was sent from the client node to the name node. Okay, internally name node, what it did, it maintained the metadata that this is going to this location, it is going to this location, and it is going to this data node to be precise. Okay, and it is getting replicated. So all this information, where it is kept in the name node, and also similarly it is kept in FS image. So I'll come back to this later. Okay, let's go step by step. So data block size was written and replication happened. Now what name node does is, because when the request is coming from the client, so the master node needs to process the data. So what job tracker does is, job tracker keeps an eye on task tracker, okay, that you need to process these tasks. Okay, so there is a job tracker and task tracker, so they will be maintaining what is the process, or what is the process, or where till where you have processed, what you have processed, and are you facing any issues. So job tracker will be tracking that, as the names itself suggests. So job tracker will be tracking what jobs are getting processed, and task tracker are the tasks which are getting processed individually. Now what this data needs to be done is, after every 3 seconds they need to send a heartbeat to their master node. What they need to do is, after every 3 seconds they need to send a heartbeat to their master node, okay, saying that we are alive. What do we need to say? They need to say we are alive. Why we need to say like that? Because let's say there is a heartbeat after every 3 seconds. So, if you remember or recall a little while earlier, when I was trying to give a small example wherein Satyajit was my team leader and Saif, Obed and Krishna were reporting to him, okay, in a similar scenario, let's say this is Saif, okay, let's take this is Saif, this is Satyajit and this is Krishna, okay, so these three people are reporting to Satyajit, okay. So how they will come to know? So if you talk about our day-to-day work, we need to give a present, means like we need to say, okay, there will be some Excel file or some attendance with which my manager will come to know I am in there in the office. And the second thing is, the team leader would be tracking all these three people. How he would be tracking? He would be tracking maybe like by let's say he would be seeing you on communicator, right? With the communicator, whether it's like away or not away, available, so he'll come to know these persons are available and they're working. So in a similar fashion, name node also needs to understand whether their data nodes are up and not. For that purpose, what data node does is they try to send a heartbeat after every 3 seconds, saying that I'm alive and I'm doing my work. Don't worry about it. So whatever the work which has been sent, so see, once this metadata is being taken, and once this name node knows where their data is being lying, and job tracker is, then the communication happens directly between your client and your data nodes. So initial communication happens like to give to a master so that the allocation will happen and the processing will happen at the particular data node. Then after that, client can directly interact, so that all internals. Now after every 3 seconds, let's say heartbeat is sent. Now let's take an example. Due to some reason, or let's say whatever the reason could be, the heartbeat is not sent by this person. After 3 seconds, okay, so the name node did not got a heartbeat from a second data node. So it will try to take a period, means like again there is a timeout period which we need to mention in the configuration, and that is all Hadoop admin work. We don't need to worry about it. But there is a cycle of, again, like it depends again on the configuration. So there is a 3 cycle sometimes, or there is a 2 cycles. So what does 3 cycle and 2 cycle means, or 1 cycle means? If I'm saying 3 cycle, so it can happen is, let's say, after every, means like after 9, means if I'm not getting, after every 3 seconds I did not get a 3 heart, means like 3 response, I will try to go to my data node 3 times, and if he or she is not able to respond, I will termed as that data node is a dead node for me. In a similar fashion, let's take an example. Saif got some emergency and he left in between, so he is not available on communicator, or he is not available on Teams. So his manager identified that, and he's trying to call Saif, but again it's an emergency, he's not able to pick up the call, but the work needs to be done, right? So your manager can't wait for Saif till the time he responded. So he needs to finish to work, because even he needs to answer to someone. So what, before that, Okay, so let's say this is now dead. Now if this is dead, I can have only, means if you see in my architecture, I am able to see only two replicas, right? I am not able to see three replicas. If you see, the replication factor is 3, but I am not able to see that. So at that moment of time, your cluster is termed as under replica. What it is termed as? It is termed as under replica. Okay, under replica, which means that your replication factor is not up to date, something is fishy or something is missing. At that moment of time, your cluster is termed as under replica. Okay, now name node identified that this person is not available. So what name node did is, as it's a metadata, okay, it needs to take care of everything. What it did, it took this piece of work from here, okay, and it assigned to, let's say, the other person was Satyajit, sorry, Obed, and the other person was Krishna. Okay, now the work is balanced, the replication is done, so the two people a little bit overloaded, but yes, still my work is loaded. Okay, but it is balanced between two people. So whatever the work was Saif was doing, now that is taken care by Obed and Krishna. Okay, now these two people are sending heartbeat. Okay, cool. Now let's say after 3 hours, when Satyajit started, or let's say Satyajit has set a status whenever people are going offline and online, he just has set a status to the mobile. Now he suddenly got a status. Someone is not on mute. Please be on mute. Thank you. So what he suddenly,
Yeah.
now suddenly Satyajit got a status reminder. Okay, Saif is online. So in a similar fashion, this person started responding, okay, which is nothing but Saif. Initially, this data node was not responding. Now this data node started responding. Okay, it came alive. Now when it came alive, what happened is the name node got to know that, okay, but if you see the work that is being assigned to other person, the other persons are also doing, as well as Saif is also doing. So that is nothing but redundant work, right? So someone has to take care. So who will take care? Manager, right? So manager either will tell Saif, Saif, as you were not available, I have allocated the work to others and they are doing is, what you can do is you can do other work which I'll assign you, or else Satyajit will go to Obed and Krishna and ask him whether have you started this work. They will say no. Okay, so don't do that work. As Saif is back, what we can do is let him do that work. Before that, this phase is called, when Saif started responding or the data node started responding, this state of cluster is called over replica. What is called? Over replica. Why it is over replica? Because the blocks are not as per your default configuration or whatever the configuration is meant. They are a little more. Okay, so after that, so you understood under replica, over replica. So after like communication, name node, okay, so these two people didn't start it. So what name node will do? Okay, if you have not started, okay, let Saif do the work. So again, the load will be balanced and they will be processing the data. Okay, so again the heartbeat will be sent by all these three data nodes to the name node after every 3 seconds. Okay, so under replica, over replica. Now we will try to understand how the processing and the backing of work is done. Okay, we understood like, okay, name node is the person who is responsible, and let's try to write few things about data node also. Okay, so let's try to understand what is data node. We understood with a small example. So there are many many instances of this process running on various slave nodes, right? That's what we have seen, right? There are multiple instances of data node. Cool. it is responsible for, so they are responsible for processing the data. Okay, that's what we have seen, right? Based on the replication factor. Okay, so your data, it can be like based on the replication factor. Based on the replication factor, your blocks will be replicated. That's what we have seen, right? And this process will send a periodic heartbeat to name node. Okay, to make name node aware that slaves or data nodes or slaves. Okay, it's a master slave architecture, that's why I'm saying slave or data nodes. Okay, so data nodes are processing if they have some work, and they are up processing, and they are and also up and running. Okay, so this is like what your data node is doing. So it is responsible to process the data, it is responsible to send the heartbeat, responsible for data replication. Okay, cool. Now, when the request is sent from the client to the master node initially, okay, so what name node does is it tries to write the same metadata to the FS image on edit logs. Again, like it has certain things. Okay, we'll try to understand. Before that, we'll try to understand this person. This person is like silently standing aside. Let's understand that person. Who is that person? Okay, that person is nothing but a secondary name node. Okay, now secondary name node, again, let's take this copy as is and let's understand secondary name node. So the third person is nothing but my secondary name node. So I'm just doing copy paste. Now there is a single instance of this process, okay, which runs on a cluster. It's not mandatory to be on your master node. Okay, it's not mandate. Okay, it is running in your cluster. So there is a single instance of this process which runs on a cluster. Okay, this process can run on a master also for smaller clusters, or can run on a separate node also. Again, it depends how large and small is your cluster, but there is no restrictions. Okay, one misinterpretation which people has is, again, you people not be having, but again, like that's what is said. One misinterpretation from the name secondary name node is has is, this is a backup of your actual name node. This is a backup of your name node. Okay, but it's not that case. We need to remember how. We will try to understand within explanation. I'm just trying to write some theoretical words. Okay, cool. It manages the metadata for the name node. Okay, and how it manages the metadata of the name node. Okay, it has a process. That process is called checkpointing process. Okay, so what is this checkpointing process? This is nothing but merging of edit logs to FS image and updating itself We will try to understand how it is being done. Okay, and whenever the it is whenever your cluster goes down, at that moment of time this FS image is sent back. So let's say whenever your cluster goes down, okay, this FS image is sent to your name node. Okay, so that it can update so that it can update and whatever the metadata is there, so that would be available. But again, like it has a flaw, we will see that flaw. Okay, we'll try to understand now. Now let's take an example from a client or a edge node. A request is coming. Let's say the request is coming at 12 o'clock. Let's say the request is coming at 12 p.m. Okay, and that is like of a 100 MB. this is the request coming of 100 MB. So what this name node is doing, it is trying to maintain the metadata, whatever the data is coming, which block it will go, what data it has, which location is going, what is the replication, everything. And the same thing will be maintained in its FS image also, same metadata information. So it will be writing certain transaction information of those things into your FS image. Okay, and at the same time it would be writing to its edit logs also. So what will happen after every 1 hour, again it is configurable, after every 1 hour or 10 million, I think it's 1 million, I guess, if after every 1 hour or 1 million transactions, okay, your edit edit logs are sent to secondary name node. Okay, let's expand this over here and we'll understand those terminologies. Okay, secondary name. Let's see what now. Let's say 12 p.m. Okay, so we'll go with the 1 hour of stress. So let's say at 1 p.m. we got one more request of 100 MB from the client. So again, internally name node identified the metadata, distributed the work to the different data nodes, okay, internally. But as soon as the clock ticked to 1 hour or 1 million transaction, what happened is these edit logs were sent to the secondary name node, and this secondary name node initially it had a blank FS image. What it had? It had a blank FS image, means zero. So after 1 hour, sorry, that got erased. Let me rewrite that FS image. So after 1 hour, what happened is, or 1 million transaction, these edit logs were sent to the secondary name node. So this FS image and this edit log was combined, okay, and this merging process is called, as I told earlier, that process is nothing but, that process is called checkpointing. What is that called? It is called checkpointing, and that is nothing but merging FS image and edit logs. Whatever freshly edit logs are sent after every hour interval by a name node. So if we take an exam, so let's say for the first hour it got built and a new FS image got formed. Okay. So what I will do, I will just erase this, and now a new FS image is there. And if we see at 1 o'clock, I have not started processing this. So let's say at 1 o'clock, this FS image and this FS image, can I say these two FS images are in sync? Yes, no?
Yes.
Okay, cool. Thank you so much. Now let's say at 1 o'clock, again I got one more request, okay, of 100 MB. Same thing will follow internal architecture. Now what it will do, what this name node will do, this FS image, it will keep on appending with the newly data, whatever like metadata transactions, what it needs to have, so it will keep. But when it comes to edit logs, whatever prior 1 hour of metadata it had, it will erase that, okay, and it will start writing the new logs or new metadata which the name node or the master node has received. So it will be starting writing from 1 o'clock. So let's say at after 1 hour, let's say at 2 p.m. okay, so here you need to understand a little bit. So at 2 p.m. if you see, this FS image is having the metadata or the pointers from 12 o'clock to 2 p.m. But this edit log is having the metadata or the pointers from 1 p.m. to 2 p.m. So as soon as the 1 hour or 1 million transaction hits, again this will be sent to the secondary name node. The new FS image, sorry, the new edit log which it brought, again the checkpointing process will happen and this FS image will be updated. So in a positive scenario, at a certain period of time, which is nothing but a configurable 1 hour or 1 million transactions of checkpointing, 1 million of means like your transactions or metadata checks, at a certain period of time, this fs image and this fs image will be always in sync in a positive scenario. Now let's take a negative scenario. Okay, so now these two are sync at 2 o'clock. So now at 2 o'clock we started one more, we got one more request from the client. It started the same process. Before that, whatever edit logs from 1 p.m. to 2 p.m. were erased. So the request was coming and it started writing from 2 p.m. to moving ahead, and suddenly at, let's say, 2:30 p.m., what happened is, due to some reason, your name node went down. Your cluster is not responding. Okay, whatever requests are being sent from the client or edge node, they are not able to, your name node is not able to respond, which means that it is giving us a message that your name node is in safe mode. Okay, again it goes, because there is a process for going it in safe mode. So but let's take that it is not able, so let's say it got failed. Okay, let's say, let's not speak about this safe mode now. Let's erase this. Let's say at 2:30 p.m. due to some reason your cluster was not responding and your cluster got failed. So now what will happen, the data which was available from 2 p.m. to 2:30 p.m., that was available in this fs image and that was available in this edit logs. But as these edit logs were not sent to the secondary name node, so this fs image is having only the metadata transactions till 2 p.m. So what these Hadoop admin people will do, they will take the image, whatever the fs image which they have till the last, before the failure, they will apply whatever they would be doing. I don't know what they would be doing. Till that moment of time, your cluster will be in your safe mode. Okay, so you will not be able to write, but you will be able to, I think you will be able to read the data. So at that moment of time, what these admin people will be doing is, they will try to bring back your name node with some mechanism. And once they have built it up, okay, so this fs image, they will be up and running, but this fs image will be having the data till 2 p.m. only, because we had the backup of that fs image till that moment of time. So here we are having a data loss. So that was one of the failure, or one of the limitation or the drawback which was there in your Hadoop 1.x architecture. That was single point of failure. We'll come back to the drawbacks, but we will try to understand. So this is one of the thing. It was not able to, so the first problem was the single point of failure. Then if one name node is not available, again this name node is not taking up the work. Okay, which means that I cannot grow or I cannot scale out my name nodes. So again, like, there was certain restrictions. So scalability was not possible in 1.x architecture. So in 1.x architecture, everything was good, everything was proper, but there were some limitations. Okay, and those limitations were nothing. The first limitation was, so the first limitation was single point of failure. Okay, why there was? Because as there is no backup of name node. Okay, we do have secondary name node. You will say this is, but again, like, we did not had the entire data from that backup. So that's why do not consider that as a backup. That was the first thing. Second thing is, in your architecture, okay, so it in like 1.x, your Hadoop cluster, can be scaled up to 4,000 nodes only. Again, that was one of the related to your nodes, but the main thing was scalability was not available. In the term scalability, when I means is, if your name node goes down, there is no alternative to take name nodes work immediately. Yeah, there is a process which happens, but again, like, I need to wait for that process, and in that process also I am having a loss. The third thing was your job scheduling, which was nothing but your job tracker and task tracker was tightly coupled with Hadoop. Okay, so it was tightly coupled, so job tracker is not able to manage resources outside your Hadoop if other requirements like other daemons are there which needs to be maintained or taken care. So job tracker was not able to do, or was not able to manage resources outside Hadoop. Only it was able to manage the resources inside Hadoop only. Okay, so that was, again, like, this is not taken, but again, the first two are the major thing. So the Hadoop 1.x architecture had a single point of failure when in the name node is going down, I am not getting my data. That is the first thing. So it was a single point of failure. No scalability was available. Okay, if I want to grow, if I like multiple name beyond 4,000, again I need to grow. Again, that was not available. If one name node is going down, there was no other person to take my work immediately in such a big cluster. My job tracker was not available outside my Hadoop if I need to handle some resources. So again, that was one of the drawback. And the last drawback was, let's say, as due to single name node, okay, there is no chance, there is no concept, I would say, of namespaces in Hadoop. I will make you understand in 2.x architecture what does namespaces in means. Okay, which means that if you see, this is a single namespace, okay, which is taken care by this name node. But again, like, we can have multiple name nodes in 2.x. That's where, like, the power of scalability of name node, which was identified in the 1.x architecture, that was taken care in the 2.x architecture. So when it comes to your Hadoop 1.x architecture, you need to understand there are two failures, or sorry, there are two drawbacks or limitations. One, it is like a single point of failure, and the other thing is scalability. Okay, so this is like your Hadoop 1.x architecture. So like I can means like now means like you can ask questions like wherever like you feel doubts and wherever you are getting hitches.
Hi, Saif. This is Satyajit.
Yes, Satyajit.
Again, actually, yeah, I'm a little bit confused about the FS image and the edit log.
Okay.
So as you said, FS image, it will read all the, metadata from the file, and then
not exactly all metadata, but it will be having some transactions, some things. Yeah, not exactly. Yeah.
So within our time period, it will like whatever the transaction will be happening, like 12 to 1.
Okay.
This will store into the edit log.
Both FS image as well as edit logs.
Okay, and that thing so will be going to the secondary name node when like within a interval, like how it is
after
going to
every 1 hour interval, the edit logs will go to the secondary name node. There it will be having an FS image, and with the current edit logs, it will be updating that FS image, and finally this edit logs will become 0.
Amish,
just wait a minute, I am not finished with Satyajit. I'll come everyone's take. Let me finish with him. Yes, Satyajit.
That's I got it.
Okay, thank you, Satyajit.
Yeah. So Amish, I was asking about the same thing. Like, so edit log will have FS image information, same information which is there in FS image.
Yes. So this FS image and this edit logs will have the same information.
Okay, and what is written in secondary node is from the edit log to that
Perfect.
FS image.
Perfect.
Okay.
Perfect.
Okay.
Perfect.
Yeah. Yeah, and one thing like under replica, right? So what is exactly the under replica?
Under replica, which means, let's say Saif is not responding. Saif is gone due to some emergency. He is gone and he is not taking Satyajit's call. Okay. So the work is allocated to him that needs to be done, right? Now, if
Yeah.
you see, this person is not able to respond to Satyajit. So now if you see, only Obed and Krishna are able to respond, which means that here if you see this, I have only one replication, right? So 1 plus 1, I'm having 2, but the replication count should be 3, right?
Yeah.
So whatever under this, that is termed as under replica. Whatever up above this, whatever you have mentioned, that is called over replica. So as soon as, let's say, Safe come backs, so the task which it had, he will start processing. Again, like name node will decide whether other data node has already processed it or not. Again, that internal mechanism. So that's your under replica and over replica.
So in this case, if it's over replica, also it will be three replication, three blocks, right? If suppose SAP's work is going to one
Nahi,
to
nahi,
obey
how
and
it?
one.
So see, under replica is good for you.
Yeah, means because there are only,
Two,
but it's
two.
three replication, right? Concept three replica, right? In total,
See, the concept
replication
is,
factor is
see,
three.
that's what I'm
Yeah.
saying. The concept is three.
Hmm.
But if it is not meeting that requirement, if it is going down or exceeding that, Hadoop or they have termed something that is called under replica and over replica. It should have three, right? Now, if you see, Safe is not responding, right? Hello, am I audible?
Yeah,
Yeah.
we can
So
hear you.
overall, all combining all the nodes, it's yeah.
Yeah, combining all the nodes, it should have three.
Okay, okay. Yeah. In that case, it's under replica.
Perfect.
Yeah.
Yeah.
And when the node is down, when you combine the work, that way it's
Again,
over
over
replica.
replica. Right, rightly said.
Yeah.
But sir, in this case, each data node, data slave is processing the 100 MB of data, correct?
Each data node is processing.
100 MB of data, correct?
Yes,
Like the two blocks.
correct. See.
So
Wait. See. Don't get over there. So I got you. So like you are telling that this will be processing this work also and
yes,
this processing. No. It won't happen. Don't go over there. Sorry.
okay,
Okay. What will happen is now let's take again like that is the internal mechanism. Okay. What can be a scenario is if you remember that distributed file system, I removed that. I shouldn't have removed. If you remember that distributed file system, like 5 records are processing here, 3 records are
yes,
processing here. Okay,
yes,
now it can be a scenario 64 MB chunk is processing by this person and 36 MB is processing by this person. This is
okay,
just a backup.
okay,
This is just a backup. It's not that 100 MB will be processing here also and 100 MB process also. Again, it will be overburdened, right?
yes,
No, nothing. That this is the way it will go. Okay?
okay, okay. So we have a mechanism like job tracker who keeps track of all these jobs
Correct.
and get the heartbeat.
Correct.
If something goes down, so it allocate the work accordingly.
Yes.
So what would be the reverse way? Suppose if my name node gets down and these nodes are trying to send the
Entire
heartbeat.
cluster will be halted.
Okay, okay,
No secondary thoughts. Entire cluster will be on halt, and then once the admin, so it will be in a safe mode. You will not be able to read. Neither these people will be able to process. Only whatever the intermediate data they have written into the distributed file system, we will be able to read the data, but we will not be able to do anything apart from that.
okay. And one last question:
Sure. No last
What is the
question.
yeah? What is the combination between client edge node and data nodes?
See, internally they are connected with some network bandwidth or network something. So even I am not sure. So internally, whenever like the edge node, the request is being sent from your edge node to your cluster, that is internally handled. So we don't need to worry about like, okay, how they are internally connected and how my request is going from here to there. We need to understand, like as a developer, when I'm trying to write the code either in PyCharm or wherever, and then when I'm trying to execute my Spark submit command on my edge node, that request is going to my cluster. Okay, so this request will be going to my cluster. So in that cluster there will be some person who will be master, and there will be few people who will be slaves. So master will keep the metadata track, and the data node will be processing my data. So from where we are pushing these instructions? From your edge node. Got it?
Yes. Thank you.
Sir Amish here. When do client directly interacts with the data node?
When do client interacts with data node? Okay, so let's say in
Yeah.
your Hadoop cluster, so let's say there are some, let's say one process has been written successfully, okay, and the data is being written into, let's say, HDFS file system or Cassandra table. Now you want to, now what you want to do is you want to read that data. Okay, either you can log into your cluster and into your Cassandra shell, you can read the data, or else from your edge node you can just write some shell script and you can call node and see the node. See, edge node is just if you talk about like let's say your Citrix environment. Let's take an example of Citrix environment. Okay, so what happens is in your Citrix or your RDP or your VM, okay, you get a client's environment like login credentials, username and password, right?
Mm-hmm.
So do you know Putty?
Yeah.
So with Putty, you try to provide the host name and whatever the things, right? And you try
Yeah.
to connect to your cluster. So your
Yeah.
Putty becomes your edge node.
Okay.
For the time being, you can just consider that.
Mm-hmm.
Once I show you the actual VM environment, there I will be able to show you what is edge node and what is Hadoop cluster. As of now, just for a small relation, when you are trying to access your cluster with Putty, consider that, because once you log in, all the
Mm-hmm.
commands you are executing on your Putty terminal, right, which is nothing but one
Yeah.
of your Linux flavor. Consider that as an edge node for now.
Okay. Okay.
Hi, Shaikh. Bharat this side.
Yeah, yeah, go ahead.
Uh, is there any specific reason to have default replication factor as 3?
There is no specific reason, but these are the guidelines or which Hadoop has came up with it. If you take an example of a let's take an example of, what should I take? Let's take an example of a laptop. Okay, so if a laptop, if you see and take a company of, let's say, HP. Okay, if they are trying to release a model, let's say that model is, let's say, I don't know, let's say HP NV. So in that, HP NV model will be always coming of 4 GB RAM, 1 TB of hard disk, 250 and whatever. As a user, now if you want to configure that, if you want to increase or decrease, that's your call. But as an organization, they are giving you that. So that's how, like Hadoop. By default, they have kept this. Now, based on your requirement, you can upscale or you can downscale. Got it?
Okay. Yeah. Thanks, Shaikh.
Yeah, yeah. Any questions? Are we able to understand? I know, like for the first time like this, for the new people, it will be a little hard to digest, but again, if you go through the recording once, you will slowly start getting a hang. In this, there are some few jargons which I have said: under replica, over replica, heartbeat, name node, data node, job tracker, task tracker, safe mode, checkpointing. These are like in interviews they might ask you. Okay, so for that purpose you need to know. So they might ask you, what is the checkpointing process, what is the heartbeat, okay, how the data is processing, how the blocks are replicated, how the replica, under replica and over replica means to you. So you need to say those things at that moment of time. Okay, yeah, someone was
Safe
asking
Arif
Oh,
question.
here.
one question. Okay. Yeah.
Safe Arif here.
Yeah, Arif.
So in each data node, how many blocks can be stored?
See, again, that will come again based on your file size. It's not like, let's say if your file size is of 1 TB, okay, so divided by like 64 MB, that will be bifurcate. Again, we need to understand what is the capacity of your data node, because again they have, because data node is processing the data, right? So they are huge in terms of storage and processing. So they have a good capacities to store and process the data. If it is not able to store, so we need to scale out the cluster
So it's based on storage.
based
Okay.
on the storage. because that's where
Uh,
your storage and processing will take into picture, right? So again, these are commodity hardwares. So if you take an example, so your RAMs could be like a 128 gigs of RAM, and your processors could be like maybe like in petabytes or something like somewhere. But again, depends on like organization to organization. It could be in terabytes as well, 500 terabytes, etc. But again, depends on your cluster and on the project and the organization. But answer is right, what you said.
so I have one question, Amish here. Like after 3 cycles, if the heartbeat is not received, so it's termed as dead. So when it comes back, then also 3 cycles are needed.
No, no, not needed. Immediately, if you see on the communicator that is on the Teams or link, Satyajit got to know safe is available, right? It did not wait
Okay.
to for 3 seconds. Immediately, it will know.
Okay. And in one of that block size, right, it's 36 only MB
Okay.
of data is there.
hmm
So there is a wastage of around out of 64,
No,
that much,
no, no.
right?
When it comes to storage in Hadoop, okay, if you talk
Yeah.
about those terms, so again, like when the data would be coming, it would be starting right from here. It would not be storing, means it would not be skipping that.
Okay, so it will get stored in that only
Correct, correct,
whatever is
correct.
remaining. Okay.
So are we able to understand, like again, like I have not written few terminal, I think data node I have written, so job tracker, task tracker, again, like it's like easy to understand, so that's it. So
So this notes you will give Sam.
yeah, yeah, don't worry, recordings and notes once means you just means like I will be sharing like I just need your email IDs. It will just take 15 minutes me to upload and share the access of notes, everything will be given, don't worry. So I'm just stopping the recording. Let's